Okay, so I am unmuted. Let me go ahead and share my screen. Just give me one quick second. Okay, so I'm trying to get this to the first slide so I don't give anything away. um, let's see, and I wanted to use the laser. Okay, cool. Could someone just validate real quick that y'all can see my screen and you can see the pointer and hear me and everything's okay?
We can hear, we can see.
Perfect. Okay, so I'll just go ahead and get started then. My name is Jordan Cahill, and I'll be presenting on mocking strategies in Python. Development oftentimes is a series of trade-offs where the developer has to choose to sacrifice between either quality or quantity. Um, Typically, the questions will be, should I implement this solution correctly and take more time, or should I implement this solution quickly, yet it may be less reliable or less maintainable than what would be ideal? So if the developer chooses to sacrifice maintainability for timeliness, the developer is often creating tech debt. If the developer sacrifices reliability for timeliness, often the developer is not testing code to the fullest extent. So, what we're going to talk about today is how we can minimize the time it takes to reliably test our code. This way, you can have more time to implement the correct solution. Because, as the Zen of Python states, there should be one and preferably only one obvious way to do it. So it would be best if you have the time to focus on implementing that correct solution. Yet something that is untested is broken. So you do also want time to test your code. So a little bit about me. I actually went to the University of Texas at Austin, and I have a degree in biochemistry. I graduated in 2018, and I've been working as a developer ever since. I am the co host and producer of a software development podcast called Namespace Podcast. I'm an avid rock climber. This is actually a photo of me at Reimer's Ranch. This is about 45 minutes outside of Austin. I'm on a route called Hello Kitty at Dead Cat's Wall. And then over here, you can see my kitten. Her name is Rem, and she loves to hang out with me while I'm coding. And then the reason why I'm here giving this talk is because, same reason as having the podcast. I would like to help build the community for developers where we assist each other in optimizing our craft. And mocking is something that, at least on my current development team, I seem to have helped add a lot of value through mocking and teaching others about mocking, because it's just something that I'm very comfortable with in Python. So I thought I may as well share that skill and spread out the value across the whole Austin development community. The first the first point that I'll hit is high code coverage does not mean a well-tested code base. So let's look at this example where you have some data that is being passed into a function as well as a Python queue. That data is manipulated in some way, put on the queue, and then true is returned. So let's check out the test. We instantiate a Python in-memory queue, pass that into the function with some test data, but then all we do is assert that true is what was returned. In reality, 100% code coverage, but ensuring that true is returned is that valuable, because its main purpose is to manipulate this data and put it on a queue. So really, the function probably doesn't even need to return true if it's just going to return true every time. So let's look at a more valuable test. In this case, we no longer have to return true. And what we're doing in the test instead is once we call the put on queue function, we will get an item off of the queue and ensure that the item that was put on the queue is the expected item. Oops, that's fine. Um, Anyway, so you can see that this is a much more valuable test because now our assertion is ensuring that the function is doing what it was meant to do. But what if the queue is not a Python in-memory queue? What if the queue being passed in is an SQS queue from AWS or some other sort of external service queue that you wouldn't want to reach out to during the test? So this is where mocking comes in. So you can see here that rather than calling q.put as I would on a Python in-memory queue, I call q.sendMessage with a message body parameter as I would for an SQS queue. And now in my test, rather than passing in a Python in-memory queue, what I'm going to do here is create a mock queue object and attach the send message method to that mock queue object, and then pass in the mock queue object to my function. And then the assertion that I'll end up making is to ensure that the mock send message method on the mock queue object was called with the correct data based on the data that was passed into the function. So this is an example for where mocking allows you to quickly create a test that is much more valuable than what you would have been able to do had you not used some sort of mock object here. And we're going to dive more into exactly what these different mocking methods are and how we can use them in other situations as well. But first, I will mention that the main cases where mocking will be required to make the proper assertions are number one, to mock an external service or a function or class that calls out to the external service so that you don't actually reach out to that service during the automated tests. For example, the SQS queue. Another
And you're on
Jordan, I
mute
think we
there.
lost the. Yeah, you muted yourself. Hey,
Can you hear me? Can you hear me now? Oh, okay. People are nodding. Okay. Did you guys hear the? I guess I'll just start with the go backward. Okay. Let me see. Here. Okay. Okay. Thanks, guys. So the main cases where mocking will be required in order to make the proper assertion is to mock an. I'm sorry. I don't know why it keeps doing that. It wasn't doing that earlier. But you can hear me now, right? Okay. I keep seeing the. I'll just keep an eye on it, I guess. um, okay. And you can still hear me with my microphone? Okay. Anyway. Okay. Cool. I'll go back to the presentation. You would want to use mocks to mock an external service like the SQS queue so that you don't actually reach out to the service. Also, you would want to mock something if to limit the size of the unit being tested. So If you have a class or a function that's at the top level of a very long process, you may want to at some point mock a class or a function. This way your unit test does not rely on the entire process for the unit test to pass, because in reality, the unit being tested is meant to be small. Okay, cool. So here's the most common Python mocking tools that you should have in your tool belt. There's really just these 5 methods that you'll want to understand the use cases for. And if you understand when to use each of these tools, you're pretty much good to go. So the first one is for the case in which you need to mock a function that is called within the code being tested. So you'd use mocker.patch and then the path to the code being tested and the function being mocked. The other case would be on an object being passed into the code being tested. So in this case, you would use mocker.patch.object with the first parameter to the method being an object, and then the second parameter being a string of the method to be mocked. Third, you also would use mocker.patch.object to mock a method on a class initiated within the code being tested. So in this case, you would just pass in the class definition and then a string for the method being mocked. The fourth case is to use a mock object as input to a class or function, since the actual input is complicated. Similar to the SQSQ, you can see that here I'm just creating what's called a magic mock object. And in the case of the SQSQ, it's just more simple to create this magic mock object and then assign a method to it that as input to the function that was being described earlier. And it's just more simple to do that than to have to import a Q object from Boto 3 and instantiate it that way and then mock the method. So this is just a way to kind of speed up your testing, because all that is really required for that unit test is that a object is passed in that has the send message method on it. So any of these mock objects above, you can pass a return value or a side effect keyword argument. Is kind of self-explanatory, I guess. When you do not have a return value or side effect assigned to any of these, what's going to happen is that when the function that is being mocked gets called, the real function is just not going to execute, and then you won't receive a specific return value. But if you wanted to pass in the return value keyword argument, if your code is expecting that function or that method to have a return value, you would want to have a return value keyword argument that's set equal to some return value that is in the same format as what the actual function or method would return. And then we'll talk about the side effect a little bit more later. So then the fifth case that's very helpful is to mock environment variables. So you would use mocker.patch.dict with a path to all the way up to the os.environ that's being imported in the place where you're reading the environment variables that you would like to mock. So as the second parameter, you would just pass in a dictionary of the environment variables that you would like to mock. I very often will pass in the clear equals true keyword argument. That's completely optional, but what that does is it just removes all of the other keyword, or removes all of the other environment variables that are already there. I just do that often, so I wanted to include that. And then the one other note I'll make on this slide is this mocker that I have here that's being passed into test pretend. If you're using PyTest and PyTest mock, this mocker will be available as a parameter anytime you would like to pass it into any test function. So I typically use PyTest and PyTest mock, but the unit test library that's built into Python also implements mock objects with the exact same spec. So any documentation that you see for PyTest would be the same as for the unit test library. So they're pretty much interchangeable. Cool, so now we've talked about how to make valuable assertions with mock objects. We've talked about the cases in which you would want to mock and some tools, but how is this gonna make me a more efficient developer? So the idea is that if you have a very strong grasp of each of these tools and when they need to be used, you can pretty much create a standard operating procedure of when to use which tool and where based on the situation you're in. And testing no longer becomes a complicated task where you have to dig deep into deciding what decisions you want to make, because really there's not that much decision making going on if you're just using each tool in the way that it's meant to be used. So yeah, I guess the idea here is that you could end up here in the middle if you become so efficient that you're pushing out code even more quickly than before. So let's get into a code example. We're going to create an online climbing gear comparison site. So let's imagine that you have a REST API, and whenever that REST API is hit, right now we're only going to have one endpoint, and it's going to be to get ropes. So whenever get ropes is hit, the idea is that our API will then reach out to APIs of clients who have ropes. Currently, REI is going to be our one client that we reach out to. So for this example, let's pretend that REI has a REST API and they're letting us have ropes. And this is actually a picture of a famous climb also in Austin at Reimers Ranch called Liposuction, which is too hard for me, but eventually I would love to do that. Cool, so let's look at the directory structure we have here. So on the base level, we have an initializer file where I initialize some settings, and then the create app file, and then we have our resources file with just one resource for now. And then you can see we have a rope controller and a rope model. And then our only client that we are currently supporting is REI, and we do have a client interface. So in create app, you can see we're just going to be adding that one rope collection resource with the ropes endpoint. And then in my settings.py, I'm just collecting some environment variables. The only two that we have defined currently are going to be the base URL for the REI API and also the REI rope path. And then in my app initializer, I just go ahead and create an app settings variable to access these environment variables as needed. And then in resources.py, we have our rope collection. And whenever we call get on ropes, we're going to instantiate the rope controller and then call fetch many on that rope controller. So for our use case, we're going to go ahead and just pass a list of clients with rope to the rope controller, since this will help us demonstrate some mocking situations. And then once we receive those ropes from the ropes controller, we will just return those ropes in a response with a 200. So then in the rope controller, we will just iterate over each client with rope and call fetch ropes on that client. All clients are configured to return a list of rope models. As you can see here, the rope model includes some typical rope qualities such as diameter, length, brand, color, and price. And then the controller will go ahead and format these rope models into dictionaries as would be expected in the return from the API. Lastly, we can look at the REI client. So whenever the REI client is instantiated with the REI settings, we'll build out this rope endpoint. And then whenever we call fetch ropes, we will just reach out using the requests library to that endpoint. receive a response and parse that response into a list of rope models to then send back to the rope controller. And I do have just a quick interface here. So Rei Client is implementing has rope, which ensures that the clients who have rope implement the fetch ropes method and return a list of rope models. So that's the example app. Now let's check out the tests and how we can use the mocking tools for each test. So first we will test our resources file, and we're going to use mocking method number 3, which is to mock a method on a class which is being instantiated within the code being tested. So if we look at the rope collection get method, you can see that rope controller is instantiated here, and then we call fetch many on the rope controller. So let's go look at how we're going to mock this. So first off, we'll create a list of test ropes, which is going to be what the mocked fetch many method returns. So typically the fetch many method would return a list of dictionaries. So that's exactly how we have our test ropes looking. And then we will use mocker.patch.object, pass in the rope controller class, which we just import from where it's defined. And then we'll say that we would like to mock the fetch many method and return that test ropes list. So you can see here that I've actually stored the return of this method as the mock rope controller. Earlier, whenever I was just demonstrating the different tools, I wasn't storing that return value. You don't have to store the return value for the object to be mocked. Even if I wasn't storing this, the object would still be mocked during the duration of the test. But I will go ahead and store this mock rope controller because it will be important to make assertions on it later on. So then we can go ahead and we can use our test client to get the ropes from that endpoint. And the first assertion that we'll make is we just want to make sure that in the response from that endpoint, we have a response body with the test ropes embedded that the mock rope controller was returning. So that's going to be our first assertion. And then after that, we can just double check the status code. Let's make sure that we called the fetch many method on rope controller with that list of clients with rope. And the reason why this part is very important is because imagine if you are testing a function that calls another function, but that function is not mocked. In that situation, you can ensure that you're passing that function the right parameters because it's not raising an error and because it's returning the expected values. In this case, because fetch many is mocked, it's going to return the same thing no matter what. So even if over here in our get method, we were calling fetch many with no parameters at all, our test would still pass if we did not make this assertion. And that would be bad because in production, we do need to pass that parameter. Make sure that you're passing the right parameters to your mock object. So that's always going to be important. You can see I assert called once with, so I asserted that it got called one time with those parameters. One other thing to note on this slide is you may be thinking, like I mocked the rope controller, but could it make sense to potentially mock the very edge of the system? Like rather than mocking the rope controller, might it make sense to mock the requests get endpoint or the requests get function just before I reach out to that REI endpoint? And that is a possible solution. You could go ahead and dig deeper into the system, but there is a bit of a trade-off as usual, because if you decide to not mock rope controller, but you dig deeper and mock the
the requests get function reaching out to the REI endpoint. What has happened now is that every time you add a new client with rope, you have to add a new mock object to this test. And it becomes a little complicated because now your rope collection test has become dependent on your clients. And that's not a terrible thing. Like, at least in this case, you can ensure that the integration between your controller and your client, and that they're passing the right models and everything, you can make sure that that all works properly. But personally, this is my preference because I think it makes the test more maintainable and also a little bit less convoluted, because if you're mocking something so deep like that, it can become a little bit confusing to the reader, I guess. If you're working with other developers and they're looking at the test, it can become a little bit confusing if you're mocking that many levels deep. So this is just how I would prefer to mock for this specific instance. So let's go ahead and look at the rope controller. And so for this case, we're gonna go ahead and do the second mocking tool, which is to mock a method on an object being passed into the code being tested. So in our rope controller fetch menu, we're receiving a list of clients with rope. So in our test, we're gonna go ahead and instantiate a test REI client using the regular placeholder app settings. We'll create a couple of rope models, and then we will pass in that object to the mocker.patch.object method. We'll go ahead and also pass in a string for fetch ropes, and then the return value, which is going to be these rope models. So that's going to be our test client that we pass into fetch many right here. After that, all we need to do is assert that that the rope controller responded with the same ropes that were fetched from the client, just as dictionaries this time. And then once again, we can assert that the mock fetch ropes was called once with no parameters. Again, it's just one line of code, but if fetch ropes were for some reason accidentally called with some sort of parameter in this code, it would end up failing. So we would like to just ensure that it's called with the right parameters. I mentioned that this is not the best solution for this case in my book. I have another test coming up next that it would be my preferred way to test this rope controller fetch many. Like that. So here we have, rather than instantiating an REI client, we're just going to go ahead and create two magic mock objects. And after we're done going through what this test looks like, I can explain why this is preferred for me. But all we're going to do here is just create these two magic mock objects. This time we can create 4 rope models. Over here, we're going to add on a fetch ropes method to each mock client. And for the first mock client, we're going to go ahead and give it 2 of the models to return. And then for the other mock client, we'll give it the other 2 models to return. Fetch many, we can call it with a list of 2 clients. And then in our assertion, we can ensure that the ropes that were returned by both clients get put into the same list, and all of them are translated into dictionaries. And again, we can do the assert called once with. So this is my preferred method for a couple of reasons. One is that whenever we were instantiating the REI client to pass in as the test client, we're coupling the test for the rope controller a little bit with the client, right? Because if REI for some reason decided to no longer sell ropes and they were no longer implementing the has ropes interface, then this test would no longer be valid and we would have to change it. So it's just a little bit more maintainable to keep those things separate, because all that's really needed here is 2 objects that have a fetch ropes method. The other reason is because with the code as it is currently, we only have 1 client to work with. So this gives us the flexibility to create two clients and ensure that the ropes from both clients get put into this same list. So that's why this is preferred for me. And this is a little bit of a combination because we're creating the magic mock objects and then also using mocker.patch.objects to add a method onto them. Sweet. So now let's look at the last test, which is the test for the REI client. So here we're going to mock a function that is called within the code being tested. And also use the tools number 3 and number 4. So we have to do a little bit of nested mocking here. And this is a common situation. And this is the type of thing that at first would seem a little bit convoluted and take longer for me whenever I was just getting used to the Python mocking library. But once you get used to it, this can kind of become a standard operating procedure sort of thing. And I'll walk you through kind of my thought process as I'm looking at this fetch ropes method for what I think needs to be mocked. So I look at this and I say, okay, so requests.get needs to be mocked because I don't want to reach that endpoint. So it needs to return an object that has a method called JSON. And when that method is called, I want to receive a dictionary that looks that the REI API would typically respond with. So there's a little bit of nesting going on here. Look at the test, you can see that I create 2 test rope dictionaries, and then I go ahead and create a test response dictionary for what that payload would typically look like. Create a mock response object using the magic mock. I add a JSON method onto that object, and then I add a return value so that whenever that JSON method is called, I receive that test response dictionary. And then the final step is to use mocker.patch, and we don't need the object this time. It's just a function. So we'll need to add in the whole path, app.clients.rei.requests.get value equal to that mock response object. So now that we have all of this set up, we can go ahead and instantiate an REI client with some random URL and rope path and fetch some ropes, and then ensure that the client is able to translate both of these ropes into the rope model correctly. And then we can ensure that we called the requests.get endpoint with the correct parameter. So this is a situation where you can see that it's very useful to double check that the base URL and the rope path have been properly joined into a full endpoint. So let's just talk about a few other tricks. I mentioned that the side effect keyword argument can be passed to mocker.patch or mocker.patch.object. So there's a few different cases that the side effect is useful for that I have come across. The first is if you set side effect equal to an exception class, you will cause the function or method being tested to raise an error, and then you can ensure that the proper measures are taken in case of that error. A lot of times it's also nice to mock the logger and ensure that the logger got called with the correct error message. So that's a good case for that. You can also call side effect with a list, and then the function or method being mocked will return a different value on each call to the mock object. So you would want the length of this list to be the same as the number of times that that mock object is being called in your test. And then you can also assign side effect equal to a function. And this function will execute whenever the function or method being mocked is executed. And this function will receive the same parameters that the function or method being mocked received. So this is useful if you need your mock object to return different values based on what it gets called with. And then just some more tricks. There's other assertions that you can make on the mock object based on its calls. We've been using assert called once with.
But you can also use assert has calls if the mock object is being called several times and you want to make sure that each time it's being called with the right parameters. And assert has calls does not ensure that those are the only calls that it's called with. So it's good to pair assert has calls with an assertion on the call count for the mock object, which is just an attribute. So you can assert that the call count is the call count that's expected. And you can also just assert that a mock object has been called with the called attribute. And finally, you can assert that a mock object has been called with parameters without specifying one call. So, as a quick summary, we talked about why mocking is valuable because it allows you to make valuable assertions. We talked about when to mock, which is when you need to avoid external services or reduce the scope of the unit being tested. We talked about the mocking tools that are available. The 5 tools that I mentioned in the PyTest and unit test libraries are pretty much going to cover all use cases. And then when to assert on what your mock object was called with, always for that one. And then how can I be a more efficient and reliable developer? If you use the proper mocking tools for each situation, then your testing process can basically become a standard operating procedure. So I like to imagine that you almost just have a flow chart in your head of what to do in each situation. And there's not too much decision making involved if you're using each tool when it's meant to be used. So thank you guys so much for attending the presentation.
You got muted again.
Oh, thank you. I don't know why that keeps happening, but that was right at the end, right? Y'all heard the rest of it? Okay. Yeah, so you can check out. Oh, no, thank you. I don't know why that's happening, but thank you for helping. Anyway, yeah, this is you can just check out the podcast. We do have an episode on test-driven development. So if you liked this talk, we do have another episode that with more commentary on other testing practices, and of course other episodes as well. And then feel free to reach out to me after the talk, or you can email me or connect with me on LinkedIn. But yeah, thank you guys so much for listening. Really happy to be here giving the presentation. So thank you. Thank you. Yeah.
I can say it out loud if you guys can hear me. Awesome. Yeah. So Jordan, thank you very much. On the Python mocking tools slide, the first one, I always have a super hard time figuring out the right path, and it's this big mess of trial and error that I go through. Do you have any tips for how to short circuit that and make that easier to get to? This one, yeah, the first one. Like, it's really useful once you figure out what the this to that to dunder this and dot that. How do you get to that point efficiently, or do you just have to master all the packages that you're using and memorize those code paths, or is there a trick? You're on mute again.
Okay. I think it's got to be something with my audio interface. I'm trying to use my fancy podcast mic. It must be disconnecting. Anyway, so that's interesting. I guess you're having this issue when you are trying to mock external like packages.
Yeah, just figuring out the path to the function.
Right. So that's actually like I personally never mock the packages that I'm using except for the public function that I'm using if I'm specifically reaching out to something external, like the requests.get, which is very simple to mock because I'm importing it myself. When it comes to mocking a package, I personally, my tip is just not to mock those packages, like I always assume that the packages work as expected.
But wouldn't you need to test your usage of the package and what it was returning? Maybe it's making calls underneath to external services that you don't want to happen, and you want that to come back.
Yeah, so
I'm trying to think of a more concrete example that's super vague.
no, it's okay. I mean, I see what you're saying. Like, for me, if the package is not reaching out to external service,
I think you're on mute again.
oh, I'm so sorry. I won't let this happen again. Yeah. So if your package is not reaching out to an external service, then you can ensure that you are using the package correctly just because as okay.
Yeah, I mean, I totally get your answer and what you're saying. That makes sense. I think I don't think there's any path around my problem. I think if you're going to be mocking a function deeply nested within some package, you probably need to understand that pretty well anyway. So you should understand the path to the function as well. So
Yeah. So I think, can y'all hear me now?
yeah.
Okay, I just unplugged my mic, so now it's going to be regular audio quality. But yeah, the idea, like if you need to mock your external package because it's reaching out to a service, I would recommend to mock that package at the level where you are calling it, rather than going deep into the package and mocking it right where that package reaches out externally. I would just mock it right at that beginning level where you have imported it. And then if the package isn't reaching out to an external service, then there would not be any need to mock. You could just ensure that you're using the package correctly because you received the data back that you would expect. That's my.
I like that. Thank you.
I have another question unless someone else says something.
Okay, go ahead.
Okay, so I used mocking before I ever used Python, but I think like 25 years ago, there was a satellite, a student satellite they wanted to put on space, and they wanted to test the software. And the idea was to actually write software, but the hardware will be emulated. It's all in C and all sorts of like other different system altogether. What does Python provide? Today there's Python. If you would do it today in Python, and let's say the software on the satellite will be running in Python, but or another hardware thing that you want to implement, how does the mocking library help implement hardware? Think about hardware now. You're absolutely hardware.
I'm truly not a hardware person, but what I can say is if this makes any sense, or if this is related to the question, one of the true challenges of mocking is to ensure that you are emulating the thing you are mocking correctly. So if you're working with libraries and stuff that have really good documentation, then it's more simple to make sure that you're using the correct return values based on what the return values would look like in production. But if you're using some new hardware system, that there's maybe that would be the more difficult piece, is to figure out kind of at what level you need to mock and what you need those mock objects to do. But personally, I'm very high level when it comes to programming. I don't get deep down into that hardware stuff.
No, that's quite okay. But the question is whether you think like, because there's a few things you can do with Python that you could not do with other languages like C. Like, you can take an object and add the attribute, so add a function that it does, and all the things that the hardware has to do. Let's say someone wrote to you an emulator of the hardware. You just have to package it. So I'm thinking about, I don't know specifically this library that's using, but some ideas maybe. I never done this. I'm just trying to figure out things that I was doing many years ago, if they can be done much more efficiently with Python today. And you're the expert on this.
Okay. Yeah, I see it in the chat. So I guess what are there Python libraries that can emulate hardware might be kind of.
So assuming that someone wrote a library that tells you, okay, this is a device that communicates, and these are the inputs and outputs, and someone wrote it to you. But you need to now, instead of running the software on a real satellite or whatever, you are now running it on Python on your computer, on your test environment. What would you do?
Well, so it's similar to Todd's question, because if you have a hardware emulator, it's already an emulator, right? And it's already not reaching out to external services. I would say you don't really have to mock that library at all. You could just test using that emulated library because it's already emulated, right?
Yeah, it's if someone did everything to you, but it's not really exactly the same, because you have to slow down time and do all sorts of things like that, because the software is not running on something like on hardware. It's speaking, but it's becoming a different question. But basically, you're saying that it's the software level. This is what you're saying.
Yeah. It's so hard for me to think about hardware, but yeah, I guess if the hardware was emulated at a software level, then it would not be a problem to just use the emulation without mocking it.
Okay. We can think about it later, but thank you.
Okay, we can talk about it later. Yeah, I'd like to. I'll have to look into the Circuit Python stuff and what people are mentioning in the chat, because this is definitely an area that I could look into more.
Raspberry Pi project.
Yeah. Cool. Yeah. Any other questions or comments?
I just had a quick question. I come from the Ruby land, so I'm familiar with testing and mocking and all this stuff, and their presentation was wonderful. Do you know of any resources that are just like a high-level overview of how PyTest should work? Like how to format your code files and all of that fun stuff? Just kind of looking for a resource on that, so that when I write these scripts for my job, that I can kind of add some tests to them.
Yeah, well, I mean, for one, it just as a quick cheat sheet, I do have this this presentation on my GitHub, so that's I guess, a quick cheat sheet, but there is an article that I think is very, very good. That's a great overview, kind of start to finish, of these similar concepts, but it's an article that is helpful, so I can send you that. Also, just the documentation is very good. So it might not be that broad overview. The documentation's more nitty gritty, but I can send the article, and that might be a good high level step. Let me see.
Yeah, that would be wonderful. And then, is it safe to assume, or does the mock test? If you go back a few slides, there's something about you had 5 use cases of mocking on one slide.
Yeah, this one.
It was towards the I think it was towards the beginning more.
This one.
Yes. So the mocker.patch, is that safe to assume that it's just going to overwrite the method that you send it? It's just going to overwrite it and return the data that you provide? Is that basically what it's doing?
Yeah. So if you include a return value, if you use a return value keyword argument, then yes, it will return whatever you provide. If you don't use a return value keyword argument, I guess, I mean, I would say it returns nothing, but I guess Python, like, it would just return none. So yeah, you would want to assign this return value if the code is expecting there to be something returned. Or, you know, a side effect, like mentioned, you can pass a list to side effect to return like several different things each time the mock is called.
Great, thank you so much. I really appreciate that.
Yeah, no problem. And then I did just find the article that I like, so I'm about to send a link to the chat once I get my mouse back. Okay, there we go. Cool. Okay. I'm reading the messages. Okay, cool. Yeah, I think I've addressed all the questions in the chat. Does anyone have anything else? Yeah. Oh, thank you. Mhm.
Hi, hi everyone. So I just want to let you guys know there might be some barking or whining in the background, and I apologize for that in advance. I have a little puppy, and he doesn't really like to stay quiet. Sorry. So that's not me, that's him. But yeah. And I can start the presentation. Just 1 second. Times. No. Sorry. So can you guys see my screen? Oh, okay, cool. And just the presentation part, right? Not the rest of it. Okay. So good evening, everyone. I'm Saloni Jain. I am a technical product manager at NVIDIA in the Rapids team. And I have a coworker, Tarian. He presented last time for the previous Python conference that we had.
PyData Austin.
Yeah. So if you attended that, there will be some overlap between his presentation and mine. I believe the first 10 to 12 slides are going to be an overlap. And I'm going to be talking more about being a machine learning task using GPUs. So it's going to focus on the QML, or the machine learning algorithm that Rapids has. And I'm going to take a deeper dive into the random forest model. Let's start. Oh, yes. So just to get a quick idea, how many of you guys have worked on data science problems before? Okay, cool. So quite a few of y'all. Awesome. And how many of you guys have used Python before for the data science problems? Awesome. Good. So I'm in the right place. That's good to know. And so, okay, so for you guys who know about it, this is just like an overview. And for y'all who have not used Python for data science before, this is just like an overview of a generalized model, or like what a workflow would look like in Python. So first would be like your data preparation step, where you're gonna have to, pre-process your data, and You're going to be cleaning it up, performing a bunch of loading your data, cleaning it up, performing a bunch of ETL operations on it. And once we have our data set ready, we generally, we pass it through a model training, which in Python we do with either scikit-learn if you're performing machine learning. But if you want to do like graph analytics, then it could be NetworkX. Once we have trained our model, the next step is to look at, oh, how well did it train? And best way to do that is using visualization tools. And in Python, we generally use like matplotlib or seaborn for visualization. And once we have seen that visualization, we tend to go back and go like, okay, now we know how it trained, and in order to improve it, we'll try and figure out, like, improve the ETL, change up the machine learning or the graph analytics part of it. So it's like the feedback loop that we have. And so now what happens is that in today's day and age, since almost every enterprise is so data centric and the data set size is increasing exponentially, that it's getting harder and harder to, get a quicker, to pass through the entire pipeline quickly. And what happens in especially in Kaggle, Kaggle challenges is that when you're trying to get the best possible results, there is a lot of back and forth, and you have to go through your pipeline and keep updating it based on what you see and what you get. And that takes a lot of time. So at the end, it comes down to maybe I should reduce my data set size, or maybe I can't run as many models or as many versions of my pipeline as I would like. So that comes down to like a trade-off between speed and accuracy, because you have to make a decision about where to stop or how much you can do. And this problem has been traditionally dealt with in the big data space. And so approximately like a decade back, Hadoop, what Hadoop would do is it would read and write the data to disk. So it would read the data to disk, perform the operation, write the data back to disk. And there was a lot of reading and writing back and forth. And that took up a lot of time. And then we got Spark, which was like, hey, you just need to read the data once. And once you've read the data, it is stored in disk on, in the Spark in memory format. And everything happens on the disk in that particular format. So there's no reading and writing. But what happened was, like fast forwarding it to today, we kind of hit a computational limit. So I'm sorry. Yes, sorry, I forgot to click. Yes. So what happened today is we kind of hit a computational bottleneck in the CPU, is where we see a computational bottleneck before we actually hit a memory bottleneck. And so in order to do that, since people thought, oh, let's use GPUs because, GPUs have crazy good computational power. And what happened is for using GPUs, we would have to read and write back from GPU memory to CPU memory while trying to interact with different applications. So like for an example, if you have you want to interact between application A and application B. So you would load the data from application A into the GPU, perform your process, and then you would copy the data back to the CPU in order to pass it to the next application. And then, again, copying it back to the GPU and all of that. And this read and write and copy and convert is what takes up a lot of time. And so so what he decided, so what Rapids was like, oh, it would be so great to get rid of all those copy and convert. And Rapids is built on Apache Arrow. And Apache Arrow, what it does, it has it has one single format for so it has one single format, so you don't actually have to convert between different applications. And so initially what you have is initially you have to copy your data into GPU, and then you can run your entire pipeline on the GPU, and there's no reading and writing. So this is, what a Rapids ecosystem looks like. And so for the data preparation, where we used to use pandas, we have cuDF. And for model training, for machine learning, we have a library called cuML. And for graph analytics, we have cuGraph. And once you're done with the training for visualization, we have cuCross filters. So you're going to be like, oh, that's all cool, but what if I have to learn another language? And since Rapids is GPU accelerated, it's based on CUDA code. And you're like, wait, I don't want to do C++. But the best part is you don't need to. It's basically like an easy, switch from your existing code in Python, which is going to be using pandas, scikit-learn, or networkx, and other these things. It's just a simple switch. So I'm going to show an example of this code. So, oh, I'm sorry, I keep forgetting to do the next one. Yeah, so this is basically saying what Rapids is we're built up using other open source libraries as well. So we have Dask, and we use Dask, we use Numba, we use CuPy, we use Apache Arrow, of course, and we're built on CUDA code. And this is also like unifying the entire GPU data science. So like I said, you don't need to convert from one part, like from one app. Like when you're jumping from one application to another, you don't need to actually convert your data. You can just keep going. It's within the GPU memory itself. And the similar APIs that I'm going to show, yes. So this is an example of a basic, Python where on the left, oh wait, sorry, I'll just get a pointer. So it's, oh, sorry, no. Pointer, I'm just trying to get a pointer. Arrow options. Oh, there it is, laser pointer. Okay, so here is a basic, yes. So here's a basic Python, a Python code which is using pandas to, well, just creating a data frame from the scikit-learn data set. And on the right is DB scan being performed on the data set. So this is your basic Python API. And when you're going to be using Rapids, the change is going to be that instead of using importing pandas, it's just going to be replacing the pandas keyword with cuDF. And on the right, when you're using machine learning algorithms, it's basically going to be changing scikit-learn, the word scikit-learn, to QML, and that's it. So it's pretty easy to, import from one to the other. You don't need to learn anything new. It's just basically your old Python API, your old Python code replacing a few words. And I'm going to be talking about, I'm going to be focusing more on the QML library, which is the machine learning library in Rapids. And under the hood, the QML library, it actually has a Python Cython layer, and then it has QML prims in CUDA code. So the QML prims is just math API, sorry. It's math prims. So it just has basic, it has the primitive algorithms implemented in CUDA for like CUDA and C++ for basic algorithms that would be like, you would have distance functions or other linear algebra primitives. And this is in case you don't want to use the traditional or like the basic models and you're like, oh, I want to try something different or I want to tweak up the model. Instead of writing the CUDA code, you can just like use these libraries and be like, and update the basic model. And the QML provides a few algorithms. So we have multiple algorithms for classification or regression models. There is an inference model as well, clustering, dimensionality reduction, time series. And these are the ones that we have currently. We also plan on adding cross-validation and hyperparameter tuning soon. And I'm going to be talking about the random forest algorithm because one, it's really liked and it's favored by a lot of people because it's kind of like a magic thing. It's like, oh, it gives you so much better results so easily. Also, I initially worked on the algorithm before I moved to a technical product manager role. So random forest is just an overview on what random forest is, just a refresher. Is it just consists, it's made up of multiple decision trees. And these decision trees are independently trained of each other. And what happens is for each decision tree, you take a subset of the data set. And then from that subset, you pick up features that you want to train the model on without replacement. So what happens is it helps to prevent overfitting, because sometimes what happens is that certain features are so strong that they are the only ones considered, and we do not look at other important features as well. And the building tree process is, well, the whole base of it. And for building a tree, the two most important choices are the feature that it gets split on, and also the split value that's chosen. And in CoML, we support 4 such split criteria that are calculated. 4 such split criteria on which we actually calculate each feature importance. And for random forest classification models, we have Gini index and entropy. And for regression models, we use random forest mean squared error and mean absolute error. Now, how is CoML, getting a speed up, or what's different than scikit-learn? And we actually don't split the model generally how scikit-learn does. We actually use a different method, and the basic difference here is that we use a splitting criteria, which is either we split the model based on quantiles or we create a histogram. And what this does, it reduces the time required to actually create the models. I'm going to be talking more about these splitting criteria in my next slides. Also, am I going too fast? Is it okay? Okay, cool, awesome. So yeah, first we're going to talk about the histogram algorithm. And what happens is, so in CoML, we actually provide 2 extra parameters which are not seen in scikit-learn, which is the splitting criteria and bins. And splitting criteria, as I mentioned, we have 2 options, histogram and quantile, which decide the way your random forest, your decision trees are created to create the forest. And number of bins actually decides the variation, or the number of features, or the way the features are actually going to be looked at. And what happens is, if you choose to use the histogram algorithm, in the histogram algorithm, each feature is actually split into n bins, and then for each bin we select a potential split value. And so here what happens is the distance between, or the width in the histogram is consistent. So it might be that not each and every histogram would have, a certain amount of the same number of samples in it, but they're split up equally. And what this does is, this method helps us isolate any outliers in the data set. And yeah, but that being said, it actually takes a lot of time, because at each point you have to split the features up and analyze everything. So in case you're like, oh, that takes too much time, and you think that your data set might not have that many outliers, another approach, and this is the default approach, is the quantile split criteria. So when the split criteria is actually quantile, what it does is it will split the features. So when it is quantile, what it does is that it will actually calculate the split value for each feature just once per tree. And this calculation is done at the root node level. And since the calculation is just done once per tree, this is much quicker than the histogram approach. And here what happens is that we're actually interested in splitting the features such that each bin will have the same number of samples in it. So previously we were considering that, oh, they should be equally spaced, like each bin should divide the feature such that they're equally spaced. But here we're like, we want each bin to have the same number of samples. So we have the same height, but not necessarily the same width. This feature splits. And this is a much faster approach. And this is generally like the recommended approach, or the default approach here. So this is just basically how we create our trees. And we also have a multi-node, multi-GPU implementation for random forest, where what happens is we actually use Dask underneath to actually split the data set between the different GPUs, like to pass around the information, we use Dask. And the data set is either split randomly or it can be replicated between workers. Now, splitting the data set randomly can be a little risky because what happens is it might not split in the best way, or so your data set might, so each GPU might not get the best information. And since it might not have the best information, the forest created on that particular GPU might not be that great. And so we have two approaches while implementing the multi-node, multi-GPU, is that we can actually, is that we can actually predict you on CPU or GPU. Now, what's the difference? So when you're predicting, so the fit is the same for both in both cases, but when you're actually running prediction, when you use the CPU approach, it is slower because yes, it's processing, it's predicting on the CPU. And in the CPU approach, what we do is we split up the model. So each GPU has its own model, created on it, and the entire test data set is passed to each version of the model. So it's passed to each GPU. Each GPU's random forest model does a prediction. We collect all the predictions, and then we either average it out for regression or we perform voting for classification. But if you're using the GPU predict, what happens is the models from each GPU, so the random forest models that are created on each GPU are actually concatenated to create one large random forest model. And this concatenated model is then passed to each GPU. And what we do is we split up the data set here, because then it's quicker because you're not, passing it to each and then you just go through the motion so much. So you split up the data set, each GPU gets a part of the data set, it gives you a prediction, you concatenate the prediction, and you get your final results. And the GPU prediction, actually, we perform under the hood using cuML's forced inference library. So what is the forced inference library? Oh, yes. So forced inference library is a library that cuML created to perform inferencing just using random forest or boosted trees. And the forced inference library works with XGBoost models like GBM, protobuf, scikit-learn random forest models, or cuML random forest. So it's like if you have a pre-trained model, you're like, I already spent so much time training my models. But now if I want to, you want to be like, oh, I want at least a quicker way to predict. So what you can do is you can use the forced inference library to load your model and then just use GPU prediction on that. So on the right, you can see there's a graph for what we did is we compared the time required for prediction by fill, so the forced inference library, on a GPU, which is a single GPU V100 versus a CPU with 40 cores. And you can see the extreme speed up seen in that. Okay, so not only is you can just, but if you're inferencing, you can also actually pickle your models in cuML for random forest. And in order to pickle the model, since we have such a complicated structure underneath, what we do is we actually train the model in cuML. We convert the model to a treelight format. Treelight is an open source library. And we convert that treelight model to bytes. And we save it in a file, or you can just use it, just how you normally pickle any Python model. And while you're trying to load the model for inferencing, the model bytes actually get converted to a treelight model format, which the treelight model, which is then converted to the forced inference library format. And the forced inference library then finally performs prediction. Okay. So I would actually like to show you guys an end-to-end workflow. Darian, I can't really hear you. There was a lot of background noise.
There was a good question in the chat before you jump in. I think.
Oh, yes.
Chung-Li is trying to answer it, but Sherry, why don't you take it?
Once again.
Define quantile.
Oh, quantile. Quantile was one of the split criteria algorithms that we use to create the random forest in QML. So we have two options. You can actually split criteria has like, two possible options you can pass in. Sorry. Is one is you're using, oh, yes, thank you. So one you're using histogram min max or you're using quantile. And yeah, so that's basically just to decide whether how you create the forests. Does that answer your question? Okay. So it's not the hardware that accelerates. Well, the hardware helps in quicker computation, right? But it's also along with that, if you analyze every little, like if we create the forest the way scikit-learn does, and we actually analyze each feature at each point, it's going to be really slow to create the forest, even with the speed up of computation that GPU provides. Oh. I'm sorry, I'm just going to go back and read the standard deviation. So it's not, I mean, the quantile here is not standard deviation kind of thing, but it's more of like we use that logic. So in quantile so it's basically how we actually, it's just a name given to a process that is used to create the forest. In that, I can actually explain the quantile again if that helps. Okay. So so what happens there is you have n number of features, and the user defines the number of bins as well. So what will happen is your features actually get divided into the number of bins that the user has requested. And here what we'll do is the main point of this algorithm is that you actually want to divide, you want to create bins such
Hey,
that,
Saloni,
yeah.
are you sharing the screen that has the slides up?
No, I mean, slides is just text, so I didn't put it back up, but I can.
Okay.
Yeah.
You're talking about quantile regressor forest?
Quantile, split criteria. There, can you see it now?
Yeah.
Okay, yeah. So, oh yeah, so what you do is the user has given you a number of bins, and you have a number of, user defines the n bins, and you have a number of features. So you want to divide the features into the n bins such that each bin will have the same number of samples in it. So if you consider like a histogram, you can think of it like you have the same height for all the bins that are created. But when you look at the x-axis, you're going to see that the width of each bin is actually very different. Yes. No, it has the same number of samples. So what happens? So this process is done for each feature. So consider one feature. So now the feature is going to have a range, so probably from 0 to 1,000, right? Yes. Yes. So this process happens for each feature in your data set. Yes.
So just because I don't know if the recording is going to capture the text, is it going to capture the text, Julia? Okay, great.
All right. So for each feature, this process happens. And the reason I said that it's a quicker way, because this process happens only once for each tree. So each decision tree that is created, this process will happen only once. So that's why it's quicker to actually just go through and create the forest with this split criteria option than the histogram option, because for histogram there's a lot more processing. Yes, for each decision tree, this process happens only once. So in the demo, the scikit-learn actually takes a lot of time. I can continue answering these questions while we wait for scikit-learn to finish. Is that okay? Okay, awesome. So this is just a multi-node. So I'm demonstrating a multi-node, multi-GPU random forest algorithm implemented by QML. And we're also going to compare its performance with, oh, you can't see my screen? Okay, 1 second. That's weird. I'm just gonna try and switch, because I switched to my Jupyter Notebook screen. Change layout. Oh, sorry, just trying to figure out how to change this. I'm gonna stop presenting and then try and present this. Is that better? Can you guys see the notebook? Awesome. All right. So yes, this is just yes, Jacob.
He wants you to zoom out.
Bigger,
Oh, zoom.
Zoom in. Sorry, wrong way.
That better? Awesome. Okay. So this is just so this notebook's actually going to demonstrate the multi-node, multi-GPU implementation of random forest. How can we use it, and also compare its performance with scikit-learn, just to give an understanding of what the speed up is and the accuracies and everything. So yeah. Oh, sorry. I'm gonna restart. Yes. Restart. I just ran it once just in case my computer decides to just disconnect me from the VPN. But yeah, so we're gonna start running it from scratch. And we're just gonna, so while you're using multi-node, multi-GPU, since we actually use Dask underneath, we need to create a client and a cluster and get the number of workers, because depending on the number of workers, we're gonna split our data set. So we're creating a training data of 500,000 samples and a test data of 5,000 samples with 20 features. And the maximum depth we're defining for the random forest is going to be 16. And the number of bins is the parameter that's used by QML. And we're defining it to 512. And the number of trees that are going to be created is 1,000. Okay, so what we do is we're using the make classification dataset of scikit-learn to create a dataset which is going to have 2 classes, and we're going to split it. Oh, I'm sorry, I didn't run this. Which one did I not? Yeah, I didn't run that one. Yes, so we're going to split it up. What happens is when you're using the multi-node, multi-GPU implementations in QML, it accepts 2 different types of input. So either it's going to accept a Dask QDF input, and Dask QDF is basically initially when I mentioned like Rapids has these different, equivalents for pandas and scikit-learn and that. So QDF is the equivalent for pandas, and Dask QDF is just QDF, multi-node, multi-GPU implementation of QDF. So the multi-node, multi-GPU implementations in QML, like the models in QML, accept either a Dask QDF input or a Dask array input. And Dask array is basically your normal, your open source Dask library. Use it to create an array. It accepts both. And here we're just converting it to QDF and then converting it to Dask QDF. And just to show that, yes, it supports Dask array as well, we're actually going to pass the test data in the form of a Dask array. And this is done. And now we're going to train the scikit-learn model. And this takes around 6 minutes to 7 minutes. So I can answer questions if anyone has any. While, you know, scikit-learn's running, I can totally answer questions.
You can continue answering what you were interrupted before, the quantiles.
Oh, yes. Well, so I believe so now I'm not sure whose question was it originally. Was it Sherry?
Sherry is repeating your answers and the questions sometimes, so you'll see them sometimes because some people cannot hear well there. So.
Oh, I'm sorry. I didn't realize I wasn't clear, or I wasn't like.
No, you're okay. Just realize that Sherry sometimes repeat things.
Oh, okay.
It's for some people to get what some people are saying. It's okay. It's normal.
Just to make sure you haven't misunderstood. Yeah, I totally get it. I do it sometimes too. Well, I do it a lot of times, but yeah. Okay, so Sherry, so did you understand an overall, like an overview of how the quantile actually splits the features? So okay, so once you have created, the features you've split each feature into the bins, and then you've picked the best value for it. What we do is then just use that for each tree, and that happens for each tree that is created in the random forest.
Maybe don't use the word features in all of those. Those can be confused. Use something like age or blood pressure. Or give an exact example of something very simple, like a tree with 2 nodes, and people understand.
I can actually show the blog. We have a random forest blog. I can show that.
Good.
And that would be like easier to, because it's gonna have examples. Okay. 1 second. There. Oh, can you guys see it? See the blog? Okay, great. I can also post the link here. Okay, 1 second. Oops, sorry. Okay. Is that little diagram visible? Okay, so this is just like, for example, if you have a data set. Actually, I should show the data set first. So if you have a data set where it's above fruits, or for example, you have a data set which is, you're trying to identify different types of fruits, and you have their colors as features. So you have red, green, blue as different features. So if a fruit is red, that feature is gonna be 1. And if it's not, it's going to be 0 for that particular feature column. And you have another feature column called size. Oh. I'm not really sure how to use a whiteboard here.
So if you open up PowerPoint.
Okay. Yes.
And I guess, and by the way, is your demo still running, or I had to walk away for a second?
Oh no, it's still running. It takes, I'm trying to find, yes, right there. It's still running. I see the little power glass there. Yeah.
Okay.
It's
Use sticky notes and connectors. That might help out. The little boxes and connectors, because I think you're looking for a whiteboarded. Just to explain through how each piece works, correct?
Yeah, like just have a small example data set and then show how it's actually doing it. So yeah, how do you use a whiteboard?
Create a new slide.
Sorry?
Create a new slide.
Oh, okay. Sorry, I've never used a
Blank
whiteboard
slide.
in PowerPoint.
Oh, you're not gonna whiteboard. You're gonna use it as a
Draw
whiteboard.
it?
Yep.
Oh.
So now take a shape, any box, or circle. You're
Oh,
gonna draw right
okay.
now.
Awesome. I'm just gonna, but actually,
And then type in what you need.
this might be easier to do. I'm just gonna copy that image from online.
It's not an image. It's a.
It's this. Let's just create a table, insert. Oh, I'll have to reshare this window. I'm gonna stop sharing because I think you guys can't see my PowerPoint.
We can see it.
Oh, you can? Oh, great. So table, I think that should be good. Paste it. Awesome. Okay. Instance 0, 1, 2, 3. All right. So if this is your small example data set, what happens is when you're using Quantile, it's going to be like, okay, it's going to take the feature red and it's going to create bins. But oh, this is like a very small data set. Oh, I'm just going to have to tweak it up. All right. So what it's going to do is it's going to try and create bins. And for example, you have 2 bins here. So what it's going to do is it's going to split the red in, oh, wait, I'm going to have to create this. So red value 0. Oh, and it's going to split it in. This is a very small data set, so might not be very clear. I can add rows though. Okay, yep. I'm gonna do this. 5, 2. I'm just gonna add more rows so it actually makes more sense. Insert. Okay. All right, so we're gonna have one more. So for Quantile, for Quantile, we're interested in keeping the number of samples the same. We want each, so if this is like, you know, your bin, like bin 0, 1, 2, each bin should have the same number of samples. So you might like split up your data set in a little different or weird way, but we need to make sure that each bin has the same number of samples. So for example, you have, oh yes, this would have been better. So what happens is right now, there's like the distance between each, like the width, if you plot these, would be like a distance of 1 between each bin. But what if you have something called 0, 0, and then you have 4 and 4 and 2 and 2? So, oh, wait, that's still even. Yeah, that's better. So what happens here now, I changed the 4s to 5. So what happens is now when you'll actually split it, it's going to be zeros, and then you'll have your twos, but then you have a distance of 3 for the last one. So we actually don't care about the width in this case. We're more interested in keeping the number of samples the same between all the bins. So now, what happens when you go to green? This is actually something I forgot, but I'm doing this, is if all of them have a single value in green here, if the entire feature has one single value, then we just don't consider it. And it doesn't make sense to even consider it in random forest or any which ways, because it's not going to give you any important information. I'm just going to check on this. Oh, awesome. So we're going to come back to that question. I'm so sorry, but I know it's getting late, and this is going to be really quick now. So as you can see that the scikit-learn took like 6 minutes to run this. And now we're going to run this for CoML using the multi-node multi-GPU model. And this is going to take like 40 to 50 seconds to run it. So the range between the, yeah, I'm just going back to the question and the explanation, which is right here. Yes. So we won't consider green. And then again, when we are looking at blue, we're more like, okay, so splitting them up makes sense. Don't care about the width. We want all of them to have same number of samples. So what here, it's also another thing is that sometimes when we're doing histogram, what could happen is, since we're actually dividing each bin, well, we're dividing the features into equidistant bins. Some of the bins might be empty because nothing falls within that range. So this process is more like we want each and every bin to actually have some value in it. So yeah, is that like, does this explanation help you guys to understand how quantiles work a little better? Okay, awesome. Thank you so much, Jacob, because I can only see you doing yes, and that's like, that's how I know, okay, I'm good. So yeah, so as you can see, QML took like 43 seconds to run this. Oh, and I would like to mention I'm using 2 GPUs here. I can actually print my workers to show you guys. Add a little thing. Print workers. So as you can see, I'm using 2 GPUs here. And yeah. So on 2 GPUs, splitting this took around 43 seconds to run. And we're actually going to run the predict because accuracy matters. That's the bottom line, right? So there is a slight difference. As you can see, scikit-learn gives you like a 98.38% accuracy, and we have a 98.06. And this is because inherently the way we are actually creating or implementing is different than scikit-learn. So this is also something that we are looking into to improve. There is an open GitHub issue, and the developers are working on it. But at the moment, there is a slight variation that you do see, and it performs slightly off, like less, but lower than scikit-learn. But there are instances, depending on your data set and all the settings that you do, your hyperparameter tuning, where we do perform better than scikit-learn. And there are times when we are slightly off. And I just wanted to show this example because it shows that, yes, we can be off, but it's because we implement things a little differently. So I'm going to go back to my presentation. Okay, yes. And I'm almost done. I promise. I know I went a little over time, and I apologize. But we're almost there. Bear with me, please. So what are the trade-offs of using QML versus scikit-learn? And some of it is that, yes, as you saw, there is a slight difference in accuracy because scikit-learn implements its, well, the way it creates trees differently than what we do. And there's another difference as well is for random forest regression models, because of the way the parallel computation takes place in CUDA, when you actually set a seed, your models aren't exactly reproducible. So there'll be there'll be a difference in the predicted results by like in the third decimal or the fourth decimal place for your regression models. For classification, it's exactly reproducible, but for regression, there is a slight variation because of parallel computation. And so what's the best case scenario for using, QML or multi-node, multi-GPU models is when you have like a super duper large data set. Because as we saw, scikit-learn takes a lot of time to go through it and actually create models or even like analyze it. And since we're using GPUs and the way we implement things, it's much quicker. And what another thing is that so the GPU implementation right now for random forest only supports data sets of float 32. We do not support float 64 at the moment. And so if you want to use if you want to use the GPU implementation, you're going to have to use float 32 data sets. If you don't want to, and if you're like, you have a float 64 and it needs to be in float 64 format for some reason, we also have a CPU implementation that can be used. It's not as fast as our GPU, but it's still good. And yes, another thing is it's important to pick the right algorithm for splitting criteria. So you can, it's just two options. So it's, not hard to test it out. But if your data set has more outliers it has more outliers, then definitely histogram is the best split criteria to use. But if it doesn't have that many split criteria and you're like, oh, you need it, like your priority is speed, then quantile is the best way to go. And so right now we have multi-node, multi-GPU implementation for a number of models. We have linear regression, random forest, k-means, nearest neighbors, UMAP, PCA, and SVD. And we plan to implement in 2020 or by the time we reach Rapids 1.0, multi-node, multi-GPU for logistic regression and DB-scan as well. And how can you get started with Rapids? So you can either build it from source. We have a GitHub repo since Rapids is open source. All of the code's there. You can either do conda install, or we also have Docker containers that you can use. We have implementation Docker containers where you're like, you just need the libraries. You can use that. Or if you're interested in playing around with the code, there are also developer Docker containers, which build all of the code from source. You're going to have this all the files in there to play around with. And on the rapids.ai channel, website, there is getting started with Rapids option, and it just gives you this little, blocks to pick. So you can literally pick and choose what you want to do and which version do you want. We have stable and nightly. So stable is like the last stable release we had, and nightly gets updated like every night, like it says. And the nightly will have like new features. It could also have like bugs and stuff. So we recommend using stable, but if there's something that you really want and it's there in the nightly, you can also go for it. Also, yes, we're going to be supporting for this release. So 0.15, that's going to be coming out within 2 weeks, I believe. We're going to have CUDA 11.0 support as well. And we have Rapids docs on docs.rapids.ai, which is you'll have docs for both nightlies and stables. Yes, that's our GitHub repository. And yeah, it's an open source, so we would love for you guys to join and help contribute and use it, post questions, issues. We're happy to be there. And we have a Slack channel called Rapids Go AI, which you can join and ask questions, or you can ask questions on Stack Overflow or the GitHub repositories. There's also a Google form for asking Rapids questions. And thank you so much. I'm so sorry for going over time, and happy to take any other questions you guys have.
So, Saloni, I'll ask the question, but we'll discuss. Look at the chat. We're discussing reproducibility. You were almost apologizing that Rapids cannot do reproducible things. Well, scikit-learn cannot do itself. I can tell you this. I ran into those problems. Scikit-learn, even if you set the random seeds, it still can produce something wrong unless you set the Python hash thing. And this happened in versions, I think it was 3.7 last year. I did this, and I was baffled with it, and I didn't know what was going on until I set the random the Python run the hash seed, and then it settled down. So I don't know what it's. Maybe builds, maybe something else there is wrong, but maybe they fixed it by now. I have no idea. But don't say that we're doing not as good as scikit-learn. Scikit-learn also at least had something to fix.
Yeah.
Hopefully it's fixed by now. Now, specifically, the question is on reproducibility. You said you cannot guarantee it. Isn't there any way that you can control the hash seed that goes into your GPUs? Something that
So the reproducibility issue is only with like regressor models, and that issue is not like, there's a big difference in what you get when you set the seed. It's more of like the third or the fourth decimal place is going to be different, because it's just the way parallel computations taking place in CUDA is that's going to happen.
You're losing me here. I don't care about decimals or whatever.
Oh.
I don't care about which decimals or whatever. For me, it's important that I'm a banker. Let's say I'm a banker today, and I want eventually to run all the computations of all the banking systems or on system X, doesn't matter what X is. I want the accounting computations of all the algorithms to eventually, if I press the button, each time I press the button, I want them eventually to come out the same, and I don't care what the number is. I trust the algorithm, guys, I trust everything. Is there a way, and it doesn't matter how to do it, is there a way using those rapids to say, okay, under those set of circumstances, if each time you press the button, you get the same number. I don't care whether it's the same as a different system. I want the same system, same hardware, press the button, and each time it will give me the same result with all those random things inside.
So I'm not a dev tech, so dev techs are the ones who actually write the CUDA program, and this came up when we were actually, testing things out and trying to see the reproducibility. And the dev techs were like, there's nothing like that they can do about it. There is going to be a slight difference in that end.
You're saying that each time you run a GPU, you will get a different result it will never be repeatable? This is what you're saying?
So there'll be a slight difference, not like a major difference. There's going to be a very slight difference, and it's not going to be for each predicted value that gives out. So maybe for a bunch of samples, it's going to be exactly the same, but for others, there's going to be variation. But its bottom line is that there is going to be slight variation because we're using CUDA in the bottom layer, and CUDA parallel processing has a few things that, there's going to be a very slight difference. But
okay. This is disconcerting. I'll tell you why. Even a lot in the science community, there's a lot of discussion on reproducible science. I can show you, like, it starts, and apparently scientists cannot produce their own work. It's a very known fact by now. So each time a scientist tells you something, asking, can you reproduce them? And they'll probably, if they're honest, they'll tell you, well, probably not. But what's happening, and this is happening, and this is across the board. It's not only banking. Banking, I gave you the symbol, is a critical system. If you get a paycheck with $1 less or $1 more, and so someone tells you it's an error of the system, then you say, I don't want that system. But I gave an example of a banker, but the same is with scientists, same with many other things. I believe that you do have solutions. I just don't know what they are. So I was hoping that you'll tell me what they are. But maybe you guys can come back with this, because I'm pretty sure that you have solutions for that, to some degree at least.
So Torin actually posted the parallel processing link to a parallel processing issue in the chat, but like the dev techs are, the dev techs are the experts in the CUDA programming at NVIDIA, and this did come up. And like I said, like I haven't done CUDA programming, so like from what I was told is that this is something like underlying problem and it's gonna be seen. But yeah, like like I don't know what else to say because
Okay,
there isn't a
honest.
solution right now for it. If like that's the best way I can say it is there isn't a solution at the moment, and
You're honest, but I believe
Yeah.
that it will be checked. It has to be checked specifically this question, because the question is not what if it's reproducible. It's questioning what is and what's not. Because I understand if you split the computation and go against in multiple GPUs and then start transferring the answers between themselves, between one and another, then the rates of how they compute and how the computers work has to do something with what data comes about and what. But I believe that if you're using like one GPU, there must be a way to actually somehow set the random seed so it will be the same thing. But I'm not sure. I'll leave it to the experts.
So.
Well, there is. Yeah, sorry.
Oh, yeah, no. So a long time ago, when we were playing with MPI, and started to get within CUDA, and this issue has always kind of been there. It is, as you said, part of the way that it's processed and the speed and the who answers first, how it's answered, how the code is how the algorithm is reconstructed as the processors finish. So there's going to be a very slight difference, but it's not going to be a very large difference. And it's something that we actually calculate within, for most of the times that, sorry, we're having a table discussion here as well. Most of the times we kind of like just put it in, right, as part of the error. Okay, so in classification systems, there is no difference. In these regressor systems, there's a slight difference just in the implementation. Usually yes. Saloni will know better, but usually yes, it is negligible. You won't notice it. If you get to the larger data sets, it becomes, you won't even notice it. And you actually live in that error right now.
You're talking about the difference between an implementation between system A and system B, correct?
I'm talking about different runs.
Okay. This is something you have to fix, because the market is is going in the direction of reproducibility. I can show you. Everyone is now in the site talking about reproducibility.
But that would also apply to any multi-core system, right?
No.
Once you unserialize something,
it's not deterministic anymore.
Yeah, they're just you have certain bounds you can put. But even with like a Xeon, if you run more than one core at a time, like if you use parallel BLAS, multi-core BLAS, there are certain situations where you cannot guarantee you get the same answer every time you run it, because it would depend on very small timing issues about when certain floating point operations complete. And really the only solution would be to turn off parallel computing. But then you would...
I'm not sure about that. You're talking about very specific, unique cases where things run in parallel and wait for each other. I'm not talking about those. I'm talking about computations that should be serial, like things that like you just compute everything like MapReduce.
Parallelize.
What?
That's how we get our speed up, is to parallelize and distribute the computation across multiple CUDA processors. So every single time you go onto a GPU and you want to get that speed up, it's a parallel system you're using. If you want to use a a serial system, you should use a CPU because the CUDA processors aren't nearly as fast as a CPU will be. The benefits you get in a GPU have to do with the parallelization and the memory throughput.
Okay, I'll ask it differently. I now understand where you're going to. You're saying that there's some of the errors, the truncation errors, the one that you take, like even in Python, you write 0.3 minus 0.1 minus 0.2, it won't be exactly 0. It will be something near 0. Or 0.1 plus 0.2 minus 0.3, it shouldn't be 0. Like try it even in Python, you'll see. And you're saying that the fact that those are computed in different orders, and when you assemble them in different orders, therefore there'll be a slight error in the computation. Is what you're saying?
It's not necessarily an error. It's how to put this.
It's a numerical error. It's defined. There's actually a definition for this. It's things that are known, and are known in every floating point processor. Basically, what I'm saying is that you have so many of them running. Therefore, each time you do all those sums, you'll get something small. Since they're running on multiple processors that are not the same, then you're getting them a little bit different each time. This is what you're telling.
Yeah, I'll go with that. I mean, it's.
Yeah. Okay.
I'm like trying to answer the question on the on the channel on the messages as well, and I missed part of what you're saying.
Yeah, but it would be better if this can be fixed. But yeah,
I'd like to.
Let's leave it aside.
So Jacob, I agree. So most commodity hardware, even extremely expensive NVIDIA products, have this behavior. And realistically, there's no commodity hardware from any competitor provides what you want. You can get aerospace grade computational systems that will actually be perfect, like the sort of things that you put that like we send to Mars, but those are incomparably slow, and realistically nobody buys that to do machine learning.
Yeah, I get what you're saying. I'm not saying that this is necessarily that bad. I'm just saying that for the sake of reproducibility, you want to be able to get the same results if you press the button. This is what I'm saying. And let's leave this aside. I think that this was discussed and we understand the issues, we understand the answers. Thank you for the honesty. I understand. I believe this limitation can go away with proper attention, but this is what I believe.
Any other questions? Sorry, Tarian, you were saying something.
You know, and what's it called again? We do have the Rapid community where we can continue on these discussions because we love this kind of we love these discussions. We love chatting with you and also your implementations and your actual needs and use cases that you would want to have, right? So you know, and you know, a lot of you are asking questions about how to deploy this. You know, Tom is asking about, you know, using embedded systems like the Jetson Nano because it's a very cheap way of getting it. But the really cool thing is that Rapids runs on, if you really wanted to try Rapids and you had a computer built since like 2014, I think, is when the 1080s came out, you have a Pascal-based processor, and if you're running Ubuntu, you can run Rapids on it. And every GPU produced since then, you can run Rapids on it. And if you don't have a GPU and you need to provision a GPU, there are many cloud service providers that will happily give you a GPU. Things like Colab or Blazing app.blazing SQL will do it for free at the moment. And you can run Rapids on it. It takes a little bit of time to install Rapids for Colab, and we may have some challenges as version 0.15 is running Python 3.7 instead of Python 3.6 that Colab runs, but you'll still be able to run Rapids 0.4 0.14, sorry, on Colab. Yeah, I know. Shaloni's like, run 0.4. So you'll still be able to try and deploy. You know, Saloni, you're going to be sharing the notebook with everyone, so you can run it yourself.
Yes.
And then also the slides. right? So, you'll be able to see what it is that we're offering. And then you don't forget to go to our blogs, and we have a YouTube channel that will show you not just random forest, but other algorithms that you can use and have a massive speed up. And that includes not just your machine learning models, but also being able to visualize your data in near real time as you work on it, and then be able to do filtering and selections. You'll be able to do spatial analytics. That's pretty fast and amazing. And graph theory, which is also like one of our claims to fame, and it's been written up about a lot. And you'll be able to try those all out for free. The software is free, the community free, and we invite you and encourage you to come join us.
So where's the? Can you put the link to the discussion thing that you said that you like those discussions? I'll post something.
All right, give me 1 second. I'll get that for you.
If you like, you can also just post it on the QML GitHub repo, because it's like a QML reproducibility issue. You can just be like, hey, what's going on? And then it might be easier for you to keep track of it.
No, that's okay. It's not that important. Like I understand the issue. I understand also the priorities, but it's important that this should be raised.
Yeah.
Because
well, thank you so much for raising it.
I know I can tell you other systems are not reproducible as well, but they're at least like everyone's going in that way. So it's eventually you'll get there. Just a matter of time. But at least you're honest. You're saying, no, we're doing it to this degree of accuracy, and you explained why, which is awesome. Because others don't. They say we're reproducible, which is not the case.
And this is only in this area. There's certain other algorithms where we're very much reproducible.
Oh, yes.
You have something without Slack?
Oh.
We have GitHub. Would you like GitHub?
No, yeah, GitHub. Anything that you can put
Okay.
like in something that
So
stays.
she
goes away in time.
Notebooks
There.
link in GitHub, and even better, the issues link, so you can write it right away.
Yeah, okay. I'll start bothering you.
Yeah. All right. By the way, does anyone have any other questions? Like, I did appreciate that Saloni took the time to actually teach us. Saloni is one of the people who wrote the random forest library and capability for QML. And right now she is and it was really special of her to come in and kind of explain it to all of us and like dive deep. So she is the person you'd want to ask for this kind of thing.
Yeah,
you have Donnie asking something. Don't forget him. He's on the chat.
Oh, sorry. I'm sorry. Someone was saying something.
Oh, yeah. So how tied to the specific CUDA release are these libraries? Like, will a 10.1 release work on 10.2?
If you're asking about the Rapids release, release we have. So when you go to the selector screen on rapids.ai/start, you will be able to choose which CUDA toolkit you're going to be using, or CUDA version you're going to be using, as well as your Rapids version. So we test for pretty much all the most recent versions, and as soon as a new version is released, we start testing, and then we will release support for it as we've confirmed that everything's awesome.
Okay. Also, if you have like older, like 9.2 version of CUDA toolkit and you want to use Rapids on that, like we have older releases. I believe it was 0.13 that we supported. 0.12 where we supported 9.2. So if you just like on the repo, if you just go to slightly older version of the branch and see, it's going to be mentioned there in the README. Yeah.
I'm just asking because so I work for Anaconda, and we just released the 4.84 release of Conda, and it's actually now enforcing the version of CUDA where it didn't in the past.
Oh wow!
Oh, wow! Yeah, that's cool.
Which version is it enforcing?
It wasn't Rapids AI, but TensorFlow ran into this issue where they were kind of slack about their CUDA requirements, and somebody just filed a complaint about our latest release because we actually enforced the CUDA version that was requested?
Well, we should be able to run the latest CUDA right now, so you won't have that problem. Maybe when 10.3 comes out and we haven't fully tested, you'll have a gap. But that's about it.
But I actually have a question, if you don't mind sharing.
Yeah.
So it's like when you say for a specific CUDA release, are you like, does it give you the option to just mention their CUDA toolkit, or like you need to mention it, otherwise it's going to take the latest one?
The TensorFlow nightly set the requested CUDA toolkit to 9.2, and prior to this release, you could install it on a system that was running CUDA toolkit 9.1. And so as of this release, you can no longer do that unless your requirements are specified as, CUDA 9, just 9.0 to less than 10.
Okay, so they don't have a package for it anymore.
Right.
Okay.
But I was just looking at your packages, and you have like 9.2, 10.0, 10.1, 10.2. So I think Rapids AI should be okay. But apparently some other GPU packages are no longer installable with Conda because they were kind of slacking the requested version of CUDA they were asking for.
Okay. Well, thank you so much. Any other questions?
Donnie was asking something. Did you answer him?
Yeah.
I think Tarian did.
Yeah, his question was, does Rapid support RHEL 7 and 8? It supports RHEL 7, and I'm just typing that it's going to use Docker or Conda. Those are the only two officially supported methods. Everyone, as it is open source, you can compile and get it on whatever distribution format you would enjoy, but we will support Conda and Docker at the moment. I even had somebody come in and ask us about pip again, because pip finally started enforcing oh man, I forgot. It was like, I forgot that's the standard he was talking about now. But they started actually doing what they said they were supposed to do. And he asked about that and I said, sure, any enterprising individual can create whatever they want. That's the beauty of open source, right?
I agree.
Okay. So, any other questions? Or any fun discussions?
Hey, one more question. So I think you mentioned it on the last talk, but I forgot. When do you actually see benefits of using cuDF or cuML in terms of data points?
So,
Actually,
sorry,
I want to hear it. No, Saloni, this is your talk. I'm just here for support. Go ahead.
So the best time to use it is like when you have a very large data, like the best speed up, or like, when you'll be able to see a really good difference or speed up is when you have a very large data set. Because when scikit-learn has to process so much, that's when you actually see it going really slow, and you can see a big difference in how well we can analyze large data sets. So large data sets, best time to use, it's like that's the best time when you should use cuML or like rapid libraries. That being said, it doesn't mean that we don't perform well with smaller data sets. We do. You will see a difference, but the difference won't be very big depending on the size of your data set. So the difference in the speed, or more like the speed up, is seen more when the data sets are larger. Does that answer your question?
Yeah, so I'm just trying to think of in terms of a number of data points. What's the good number kind of guesstimate?
It depends what you're doing. Is it more, so for
your rows and the amount of columns that you have?
Yeah, it's a very case to case, depends on the shape of your data set.
Yeah, so I mean, put it this way. If you have 4 columns if you have 4 columns of in data, it might be a few it might be a few it might be a few might be like 10,000 to 100,000 rows that you would go through if you're talking about data set size, but it's really on the gigabyte. So I'll just explain to you a little bit about where that latency comes from, that crossover happens. It's when you want to transfer that CPU or host memory, that data from host memory to GPU memory. That's basically our latency. And however long it takes for scikit-learn to process, as long as it's shorter than that latency, and then our processing time, that's basically the size that you that's basically the size that you're going to have that crossover happen, where okay, rapids is actually more and more useful. We like to say gigs, but it's hundreds of megs also works, and especially when you're doing even you can, I wouldn't say tens of megs, but I would start saying like 100 megs, 200 megs in terms of data size. It really shows off. Unless, and that's if you're doing QML. When you're doing graphs, it doesn't take much. When you're doing spatial, it doesn't take much.
Okay.
We have some decent. Saloni, can you pull up? Let me find the. We have a decomposition notebook that compares doing decomposition. I think I showed it last time. Did I show it last time? The decomposition notebook? You wouldn't know, Saloni. I think Jacob saw it. So basically what we do is we show the decomposition methods of rapids, and we run it against scikit-learn's this notebook that we found on scikit-learn, right? And what we end up doing is that we run TCNE, PCA, and UMAP in a few different iterations.
Oh yeah, I remember now.
Yeah,
you did that.
Yeah, so you can actually play with that. We 10x'd our data set on versus the scikit-learn, and we were still it was like 10 times faster still.
Yeah.
It was, yeah, and that was only a few, what was it, 1,000 versus 10,000 samples, I think it was, or 500 versus 10,000 samples for the data. So, you know, that's what I mean. Like it really depends on the algorithm that you're going to be using, because each algorithm in rapids has a different speed up. Graph is in orders of magnitude of like 3 and 4. So is spatial, and it goes beyond that depending on whether or not you're using your laptop versus a cluster. And QML is, you know, in factors of 2 and 3 usually. So not factors, I'm sorry, orders of magnitude of 2 and 3, depending on where you're on the algorithm that you use and the size. So you know, like I said, it really just depends.
Mm-hmm.
And I apologize, I can't just like hand you a number, but you know.
Yeah, I get it. So I mean, I knew the bottleneck used to be like transferring data from memory to the CPU. So
yeah,
there's always a bottleneck for anything.
But the good news is when you get a data set that's big enough to actually read it, like that, you actually get to see the speed up. As it scales out further and further, cuDF maintains a really nice speed up of about 15x on reading data versus pandas. So I've had friends who are like, it takes like 30 minutes to read pandas. Why do you keep like asking me to do it again and again? And I'm like, bro, were you using rapid? He's like, no. And I'm like, dude, it's like 2 minutes, man. 2 minutes. You know, washed your hands, got a snack, and came back, and you'd be done.
All right.
Any other questions from anyone else? And we have, you know, we have the Rapids community. We have just released Rapids community notebooks, so you can play with a few of our older notebooks with this, you know, and even help maintain them. Right? This is a community effort. We hope that you will come and join us. on rapids.ai, on the on the Slack community, on the notebooks repo, and GitHubs, and even on the YouTube channel that we have, where we, have great conversation like this. Like this meetup will be posted out. I saw those evil eyes, Saloni. Um, and and if that's recorded, it's in there now. So we're trying to make sure that our education of rapids and just this capability is for you to enjoy and peruse at your own leisure and to add to. We've got many people making videos, writing blogs, and we invite those people to come through, and there's always some good times to be had. Oh, Julia says it's in there.
I want to add something for the recording while it's still here, so we won't get any misconceptions. If someone is listening to this, they might think that Python is like a big problem for disability. No. This is Python is actually Python libraries are doing much more than others. Because, for example, since Python, I think 3.6, maybe it's before, they removed the hash, the Python hash and stuff like that, and now the dictionaries are in order, like they no longer are hashed. So this is one example of that many other languages don't deal with, that Python did deal with to help reproducibility. I believe that Python is the more reproducible language than many others. You can argue about that, and I believe someone will, but it's important for all of us to know that some things just take a lot of time to fix, and Python is still the language of choice for scientific computing for a good reason. It has the best tools. So, and some of them, as long as we're honest in saying what can be done and what cannot be done at a certain point of time, we're good. It's more important than saying things that we cannot do. So thank you for Saloni for your honesty, and thank you for as well.
Yeah, I'm giving Rei Saloni.
Thank you, Jacob. Thank you, Darian, for helping out.
No problems. I always got you.
Yeah, he has way more experience of presenting than I do, way more.